I'm Jackie with DMT Institute, and today we're going to talk about finding area of triangles. Before we get into that, though, we're going to reference back to a few things that ideally would have happened in some earlier years, but also the things that we're going to tie in as we start to talk about area of triangles. So it all goes back to the idea of the area of a rectangle. And hopefully, as we've had conversations with area of a rectangle in earlier year, we've really focused on the idea that now, as we're moving to area, that we are measuring in square units, that we really want to highlight this idea and talk about that square unit and how we're taking that square unit to cover a space. We can then start to talk into the dimensions that we often use. So here, we might say this is 4. And what that 4 is telling me that it's 4 square units fit along that side of the rectangle. And then I could take that and iterate it 3 times. I could also say, well, this has a measurement of 3, which is really saying it takes 3 square units will fit along that side of the rectangle, and then I could iterate that 4 times. So hopefully we've had some of those conversations with students to really make sense of those square units, because we're going to continue to measure area in square units, although now our figures may not always be a rectangle, which is going to be a little bit more problematic. So let's jump into triangles. So with triangles, we're going to move through several different types of triangles. However, we're going to start with our right triangle. One of the reasons we're starting with our right triangle is because we're going to tie it to what we know about the area of a rectangle. And conveniently, our right triangle has that right angle, or 90-degree angle, that's going to allow us to make that connection a little easier the first time around. So I might think about taking this right triangle, I'm going to duplicate it, and then I'm going to rotate it. So we can imagine making a duplicate of this, a copy of it, and then we're going to rotate it 180 degrees. And I end up with right up there. So now I have a rectangle, and I can think about finding the base of the height, which when we're going to transition to those words with some of these. So our base and our height, I can multiply the base times the height to get the entire rectangle. But to get back to my triangle, I have to divide that in half because it's only half the space. So I would maybe think about dividing it by 2 to get back to that space. So again, it worked pretty nicely with that right triangle, but now we're going to move into, well, does that still work if I start to use something like an isosceles triangle? And we remember that on our isosceles triangle, something we know from the properties is that 2 of those sides are going to have the same length. That's going to be helpful as we look at our different ways to prove this. So with our isosceles, what we're going to do is we're going to start right here, and we are going to, in this case, actually partition it into 2 equal triangles. And we're going to take both of those, and just like we did over here, we're going to duplicate, and that 180 degrees. There we go. So we can see this half was mirrored over here, and this half mirrored over here, or rotated 180 degrees. So we still have this idea of my base times my height. But to get back to that original isosceles triangle, it's really only half the space. So I'm going to divide it by 2. The isosceles, though, there's another really cool way to do this. So we're going to start the same way we did. We're going to take right here, and we are going to, right at the top of the height, and we're going to partition it into 2 equal pieces. Now, because it's 2 equal pieces, again, going back to those properties of an isosceles, we can actually take this piece, rotate it over here, and we end up with this rectangle right here, which is going to lead us to maybe a slightly different way to think about the formula. Because now if I just look at this rectangle, I don't have that entire base of the triangle anymore. I really only have half the base, but I'm going to multiply that by the height. So oftentimes when we look up the formula for finding the area of a triangle, this is the one we see, as we know that multiplying by a half and dividing by 2 are inverse. So those 2 things are still going to result in the same thing, but visually we kind of see it differently with those 2 different ways of looking at it. So we've looked at right triangles, we've looked at isosceles triangle, but in order for this to be a formula that we can use, it should work on all triangles. So we're going to take a moment, and I'm going to ask you to pause and experiment with some other triangles. Is this still going to work when I start to get into maybe a scalene or looking at things a little bit differently? So maybe try some triangles, see if you can figure out where that formula is, and then come back and we'll talk through it. So pause now and explore a little bit. Okay, hopefully you had a chance to mess with some triangles there. So what we're going to do is I'm going to draw a scalene. And as I'm doing this, I'm realizing I kind of have this habit of always drawing the base here. That orientation, we want students to be flexible with the orientation, so I may even draw it like this. We really want to be flexible with that orientation as well. So we could go here, and we're going to do the same thing. I'm going to start at my height, And the most important thing, again, because we're tying it back to the area of a rectangle, is that I'm making those 90-degree angles when I decompose. So I'm going to go here, That's where I'm going to decompose, again, creating those 90-degree angles. And now I can think about duplicating those. Reflect, rotate, there we go. And I'm back to my base times my height. And then I've got to divide by 2. Let's take a look over here, because again, if we change that orientation, it's still going to work. So we can imagine this has just been picked up and rotated 90 degrees. But same idea, whenever I make that, when I'm decomposing, the most important thing here is to make sure we're making that those 90 degrees. So I might start here, and I still have those 90-degree angles. So same idea, just different orientation. It's important for students to explore that too, so we don't think those triangles always have to be in one particular area. So hopefully that helps a little bit with finding area of triangles, and we'll see you next time. Thanks.